Oops, what the heck? Cancel.
Yay.
Ah, I did it again. Cancel. Yeah, whatever. Okay. Some laws that you should know about exponential functions. They're the same as the laws of exponents, so it really doesn't change very much. Base times base, you add the powers. Anything raised to a negative power is literally 1 over that base to the power positively. And a to the 0 is equal to 1. And on, what was it, Monday? We defined the function f of x equals b raised to the x as an exponential function as long as b is greater than 0 and b does not equal 1. I think that's as far as we got. All right, so today we're going to continue on and graph. And we'll pick a base that's nice. 2 is a good base. Even though we'll graph 2 to the x, it's the same look type graph, like if we're talking about x squared, it has the same basic shape. If you did 3 to the x, 4 to the x, 5 to the x, whatever, as long as it was bigger than 2, they generally have the same shape. So if we're going to graph it and we have no idea what to look for, we do a table. What value should we pick?
Definitely not negatives.
Definitely negatives.
Definitely not.
Definitely. You want to start in the negative land. So you start with something like negative 3. So what's 2 to the negative 3? No.
1 over 8.
1 over 8. Already making mistakes. Look. Anything raised to a negative exponent is a fraction. Negative 2.
1 over 4.
1 4. Negative 1.
2. 1 half.
1 half. 0.
1.
1. 1. 2. You're right. 2. 4. 3. 8.
4.
All right, so when we graph this, we really aren't going into the negatives on the y, so I'm just going to concentrate on the top portion. So if this is negative 1, negative 2, negative 3, make this 1, 2, 3. I'll need 8, so 1, 2, 3, 4, 5, 6, 7, 8. There. And then 1, 2, 3. It's not going to be perfect, but it'll be close enough that we can talk about it.
What about the fraction?
We'll squeeze them in there somehow. So if we plot, let's do the easy ones first. 3, 8. That's way over here. And 8 up. It's probably a little too high. 2 goes to 4. 1 goes to 1. I'm sorry. 1 goes to 2. And 0 goes to 1. Those are the easy ones. All right. Now the fractions, you're just going to have to kind of wing where you think they're going to be. Half isn't too bad. So negative 1 1/2 is like right about there. 1/4 is going to be closer to the x-axis. 1/8 is going to be closer to the x-axis. But they'll never, ever, ever touch the x-axis. Half of a half of a half off to infinity is still something. It gets really, really close to this x-axis, and we'll give it a name eventually. So this graph, after it hits 0, 1, shoots off like this, and it grows exponentially. That's how you describe its climbing. It gets almost vertical if we go out far enough. On the other side, you can still say it grows exponentially, but it's growing down exponentially, so we call that actually decay. And as it goes down, it's going to approach the x-axis, but it's never, ever, ever going to touch it. Even if a graphing program, it'll look like it's touching it. It technically is not.
The decay.
It's decay on that side, so this is exponential decay. if you move in this direction, which is opposite of what we normally move in. So as you move to the left, it's decaying. As you move to the right, it's growing. Eventually what we're going to do is take the graph and flip it so it's decaying in this direction. We'll do
And
that.
it's growing in the other?
Hmm?
Would it be growing now?
Well, usually when we do it, we cut it off here. And we say on the first quadrant it's growing, or on the first quadrant it's decaying. We kind of ignore the other half of the graph for word problems that you're having along. Oh, did I say word problems? Isn't that horrible? So, one of the features that's going on here is what's called a limit. If you haven't seen this, if you ever take calculus, this is all over the place and you'll get sick of it. And what we're going to say is the x values are going off to, in this case, negative infinity. That means as we pull this graph further and further to the left, what's happening to the y value?
It's getting small.
How small?
Small enough but not touching. Small enough
So it'd be
but not
really, really close to
X. Zero,
zero
sorry.
as a y value. So if I take this, it's going to get close to 0. So when you say the limit as x goes to negative infinity of this function is equal to 0, it doesn't mean it's really equal to 0. It means it's really, really close to 0. So this is
That's an L, right?
yeah,
Just zooming there.
really, really, not very
Wait.
mathematically,
So can you
close to 0. Really, really close to 0.
Can you say like the limit is like explain limit again?
Limit just means as I go in this direction, what value do I approach? I'm not getting there, but I'm getting really
so X
close,
is
close to it.
okay.
Because half of a half of a half of a half is going to get so small that you could almost make it 0, but there might just be a little portion of it still being positive.
So that phrase right there just means it approaches it.
Uh-huh.
Okay.
It's really, really. So, when you get this idea that a limit is equal to 0, this is also called a horizontal asymptote. E-tote.
I
All
didn't
the
pay attention at all.
That's an asymptote. Something like that. I used to know how to spell really well. Oh well. So if I ask for just a general sketch of an exponential function, how many points do you plot? Just one. All I'm looking for is this point
And then you're just gonna
and an indication of a horizontal asymptote and some growth. So that would be the sketch of f of x equals b to the x, where b is bigger than 1. Where b is bigger than 1.
What would happen to the graph itself if it was 2 to the x power 5?
We'll get there. Trust me. We'll get there.
You should put numbers in front of it.
Or put numbers in front of it. Or any conglomerate transformation that we did before. Because now we have a base graph, we can move it all over the place.
Oh, okay.
Yeah, isn't that awesome?
No.
Not really.
No, you don't like that? No, too bad. So, for example, what if I want to graph g of x is equal to 1/2 x?
Thanks, Sam.
It looks exactly the same.
No, I said thanks,
It
Sam.
would be
Well, if you don't know, do a table. X, g of x, start with -3. What is 1/2 raised to the -3 power?
1/2 x to the negative 3, and it's gonna be
8.
8.
yeah.
Because that negative power is going to take the
1/8.
fraction and
Flip it.
flip it. So -2 is going to
Be 4,
4. -1,
2,
2, 0.
1,
That 0, 1 is a nice little coordinate. 1,
1, or
you're right.
8.
1/2, 2,
1/4,
1/4, 3,
1/8.
1/8. So when I draw this graph, I'm not going to draw a very big picture of it.
It's gonna be.
Which way is it going?
It's gonna be going
Maybe your
like this.
decay.
But
It's going to start high and
Yeah.
exponential grow on the other side. Here's 0, 1. It's going to go up on that side because at the negatives it's going higher. And then as you come into the positive x's, it's going lower. So you get that horizontal asymptote still being the x-axis, except it's approaching it on the right-hand side. What did the graph just do?
It reflected over the y-axis.
So what makes things reflect over the y-axis?
Fraction.
No.
Negative.
Negative on what?
A
The-
fraction. A fraction.
I'm not talking about fractions. I'm talking if we had a function and I said this graph reflected over the y-axis. What did I negative? The x value. So this must be the same as something raised to the negative x. What is that something? 2. So when you see a half, you can always change it as 2 to the negative x. And it's easier to understand because 2 to the negative x is just reflected over the y-axis. Looks over the y-axis. So what if I had f of x is equal to 1/3 of x? What would that be the same as?
Negative 3 to x.
3 raised to the negative x. 3 is not changing.
Yeah.
It's just becoming from 1/3 to 3. That's using one of the special properties of exponential or exponents. If you have a over b raised to the -1, that's the same thing as b over a. It's called the reciprocal function, where you can flip things over, fractions. It's a precise definition of what it means to be a reciprocal. Okay. So what do you think about this function? First question. Can I add the two 2's together?
No, because the exponent on the first 2 is 1.
Yeah, this locks this 2 in. You can't touch it with that 2. Now, if it was 2 times 2 to the x, can you put it together?
Yes.
What would it be?
4.
Oh.
No.
It's 2 to the x times 2, right?
2 to the x times 2 is what?
It's 2 to the
2 to the x times
It's
4 times 2x.
2 over x plus 1.
Let's-
2.
How,
2
back up
to
a
the
second.
x plus 1.
Ready? What is 2? For everybody else, you did get it. If I have 2 to the x plus 1 times 2 to the 3x minus 1, what's that equal to?
2 to the 3x minus 1 plus x plus
Which is
1. 4x. Yeah.
4x.
I'm sorry, I didn't know if there was.
The laws of exponents don't change. Base times base, what do you do with the exponents? Add them, and the base stays exactly the same. So be careful. I love when people go, oh, 2 times 2 is 4. I put a 4 there and mess it all up because you can't change the bases under exponentials. All right, what does this 2 on the outside do? Up 2. That's it. That's all we're doing to this graph. We're moving it up 2. Ooh, I put a big line in here. Where'd that come from? I have to erase all this. There. There. So if it up to this graph, what we're going to want to do, and you really have to do it this time, you have to go 1, 2, and put in an imaginary axis. Why do you need this imaginary axis?
Because that's a horizontal asymptote.
It's going to be a horizontal asymptote, but if you don't draw it, your graph is going to look weird. It's regular 2 to the x, so we're just taking the graph that went through this point and moving it up 2. So it used to go through 0, 1. Now where is it going through?
0, 3.
0, 3. That's up here. It's always going to be 1 up. If it's not, then change in any other way. All right. Is it high or low on the left-hand side?
It's low.
It's low. So your graph is going to come along this horizontal asymptote, hit this point, and shoot up. And you get that graph. Pretty easy, right? Exponentials are real easy to draw, but they're also real easy to screw up. All right. How about let's make it harder?
For your sake.
Let's go back to f. F of x is equal to -2 minus 3 raised to the x plus 1. What's the -2 do?
Down.
Down 2.
It's gonna be right. It's gonna be left 1.
This one makes it go left 1
And it flips over the x.
and flip over the x.
Doesn't the 3 change? Does the 3 change it?
Does what?
Does the 3?
The 3's the base. As long as it's bigger than 1, we're safe with our normal graph. Remember, if it becomes smaller than 1, it flips. But we can always change that back to a base bigger than 1. That's what I hope you do. We'll have one of those in a second. So when we draw this, we really need those imaginary axes. So down 2, down here. And what was it? Left 1 from up there. Left 1 here. Gives us a nice reference picture. Now we're not going to plot the intersection because this graph doesn't go through the origin. It goes a little bit high or low. So it's in this location. That's good to know. What else do we know?
It flips over the x.
It flips over the x-axis. So originally it was along the x-axis, went through 0, 1, and shot up.
It's going to be.
If it flips over the x-axis, it's going to
the
go
negative 1.
down. So instead of going through this point, which I would expect it to,
It's going to go through.
this one down here. So this is what, negative 1, negative 3? And it, which way is the horizontal asymptote, left or right?
Wait,
Wait,
say
the
it
right?
again?
Where's the graph approach to the horizontal
Oh,
asymptote?
the left.
The left. So it approaches along here, goes through this point, and exponentially grows downwards in this case. Because it got flipped over that horizontal line. So far so good? Great. Domain.
Just give me
Negative infinity.
the domain.
Negative infinity, positive infinity. Range.
From 1
From
to
0.
infinity.
From
Or
0
from
with the
it-
parentheses.
Yeah.
From
0,
where?
I'm sorry.
0 with parentheses to
Infinity.
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 I'm
Range.
sorry. All real. Or no,
Domain's
range,
all
I'm
real.
sorry.
Range.
0.
No, it's not. It's
It's
2.
it's 2.
It's
2.
2.
We're pushing it up 2 units, so it's 2 to
Infinity.
infinity. Range.
Negative 2.
Negative 2
Negative
is not
negative.
included.
Negative infinity.
Negative
2.
2.
Negative 2.
Negative infinity to negative 2.
Yeah.
But the domain of each and every one of these is, All real
Is
numbers.
it always going to be all?
for exponential functions, yes. The ranges get messed up, but the domains are perfectly fine. Last transformation. G of, yeah, transformations aren't that exciting with these functions. G of x is equal to 2 minus 3 times 2 to the x minus 4. Yeah. What does this 2 out front do?
Up to.
Up to. What does this 4 do?
Right.
Right 4. What does this 3, just the 3 do?
It,
Moves it towards the
yeah,
vertical.
you have
Closer to the vertical. So closer to vert equals negative 1 plus 1/3 x plus 2.
For the g of x, it should actually be 4 negative 1, just saying.
Huh?
I just plugged 4 into for x, and it should be 4 negative 1.
You plug in 4, this is 1. This becomes negative 1. Yeah, you're right. Why would it be 4 negative 1? Yeah. Oh, I put -2. I'm sorry. 1,
Yeah.
2, 3, 4, -1. 1, 2,
You're
3
going
times
back
as
from
far.
From the original point.
Yeah. 3 times as far. All right. What about this one?
Down 1,
-1, down 1,
left 2,
left 2.
closer to 3.
No, this has
Oh,
nothing to do
wait,
with the
no.
coefficient sitting in front. This is the base.
That is,
It flips.
Over.
yeah, it flips over the Y.
Because it's smaller than 1, this one flips. Y-axis. Now, if you rewrote it, it would have been 3 raised to the -x minus 2, and that gets very confusing. If the negative is up here, take this piece off to the side and write it as -1 times x plus 2. It's still moving 2 to the right, and this -1 tells you you're flipping it over the y-axis. So this is one case where the 1/3 comes in handier than the negative exponent. So, down 1. Oh, didn't draw it horizontal. Left 2, someplace over here. So this is x equals -2. This is y equals -1. Where's the point go?
On the x-axis.
On the.
On the x-axis.
It actually goes on the x-axis. It's 1 high from here, and this has a coordinate of -2. So this is going to be -2, 0. Would be the coordinate of the one point we're going to plot. Since it flips over the vertical line,
Wait, I have a question.
go for it.
How do you you know how after you plot those dotted lines, how do you know
Yeah.
where that point is?
Well,
in the zone?
once you cross these,
Mhm.
the natural graph is always going to be 1 high.
Yeah.
If you flip it over the vertical, it's going to be 1
Low.
low. This one, because of the 3, it actually moved 3 low.
Yeah.
And I should have just kept that idea in my head, but I was just trying to be fancy. Don't do fancy. Don't do fancy. So this is a normal graph. There's no coefficient up here except 1, so it's 1 high because it didn't get flipped over the vertical.
Okay.
So then, now all we have to do is decide, is it hugging the horizontal on the left-hand side, or is it hugging the horizontal on the right-hand side?
On the right.
On the right-hand side. So put that in
Because
first,
it's less than.
and this one is going to go that way. Hey, that works. Okay, what's left? We have time, don't we?
On 2.
Oh, we got plenty of time.
What's that?
Trying to get a
What's
hard
that?
to get $5
No way. Right about that. What's that?
Trying to get a hard to get that $5
Hard.
Yeah.
Calculator time, so make sure you have your calculators out.
Oh, I'm calculating.
You need mine again.
Handy dandy.
I'm gonna charge your rent.
What about? Well. We can solve it. Okay.
So in your calculator, you type in parentheses 1 plus 1 over 100, parentheses caret 100. And get me an answer. Let's say this is
Or
y.
you could just put.
Y equals.
Or you could just put the function in the y equals and then put it in the table.
Great. Some people don't have TI 83s, 84s. They have cheapies.
Cheapos.
Cheapies.
2.70481.
That's good. 481. Eh. All right. Let x equal 100,000. Well, let's just go up to 10,000. 10,000. So 1 plus 1 over 10,000 raises to the 10,000th. 10,000s. What?
Hold on.
I got you.
10,000. 10,000.
Oh,
They have to be
oh.
exactly the same number, otherwise it doesn't work.
2.718.
2.718, blah, 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 blah. Now, what's cool here is the 2 is fixed. You would think, you're raising something to 10,000ths power, the thing is going to take off, like our exponential functions. So the 2 is fixed, the 7 is fixed. What's after the 8?
Definitely a 1.
1, 4.
1, 4? All right. So let's do x equals 1,000,000.
It's like sort of switched around.
How many zeros is that?
6 zeros.
1, 2,
7-digit salary.
2.71828.
2.71828.
Yes.
I'll tell you that all those digits are fixed.
So
If you
at
went to
that point, it's done.
Huh? No, this keeps growing. It's like pi. You can always find the next decimal place. So the first decimal place we found was 7. The next decimal place we found was actually 3 of them, 1/8. Then the 1 here changed to 2. So that one's now
going to be
fixed.
fixed.
And if you keep finding, using larger and larger values for x, you'll keep finding more and more of the decimals. How many do you think exist?
A lot.
Infinite.
Infinite, just like pi. It's an irrational number that goes off forever, and you'll never ever find all of them.
So what happens if it fixes?
So if I do this forever, remember this notation?
Ever and ever.
If I let x go off to bigger and bigger values of this thing, 1 plus 1 over x raised to the x, it's going to equal a number. It's an irrational number, and we're going to call it e. Also known as the natural number.
What makes it natural?
It applies to a lot of life sciences,
Like what?
population growth, radioactive decay,
Science guy over
continuous compounding of money.
Stuff that
Oh,
is-
yeah, your money.
Money? Yes, we're going to do a money one.
No.
Oh gosh, yeah.
here. I'll just go to the bank for that.
I just go to the bank for that.
An account.
Money time.
Right?
You should have learned this formula sometime in your past.
Never heard of it.
What is it?
Yeah,
I don't
of course.
remember it.
You don't remember it?
Nope.
Yep.
Wow.
Compound interest.
That's probably why I don't like it.
P is how much money you put into the bank. A is how much money is going to come out of it after earning interest for a period of t time in years. N is the weird one. N is how many times you do your computation of interest per year. Most banks do it.
And,
How many times a year? If you have a savings account.
How many times I do what?
How many times do you earn interest on a savings account per year?
Good day.
How many?
3, 6.
12.
12. One for
Why
each
12?
month.
Every
One for
single
lunch.
month. They do a monthly rate. So if you say it compounds monthly, in other words, they calculate how much interest you earn every single month, and then the next month you earn interest on the interest you earned the previous month. That's why it's called compound interest, instead of like simple interest, which you calculate at the very end of what you're looking at. So n equals 12. What if I said compounded daily?
Then
You're
it'd be
picking up
365.
365.
365.
366.
365.25.
Huh? Okay.
Leap year. 1 day every 4 years.
Yeah.
Certain bank accounts do compound daily. If you were a child below the age of 13 at the credit union, they compound daily. The fat cat account, yeah.
I had that.
They compound
I remember
daily.
that.
So if I put $5,000
More fuel.
at 5.5% compounded monthly for 15 years, how much am I going to have?
What does P stand for again?
P is principal, which is how much money you start with. A is total amount, but A usually stands for how much you end up with.
Plug it in.
You just plug it in. Simple formula. So you get A equals 5,000, parentheses 1 plus
If we have a rate of
0.055
0.55 is your interest rate
over 12.
over 12 raised to 12 times 15. When you type it in your calculator, you either have to do this, put parentheses around the 12 and the 15, or figure out what 12 times 15 is first, and then go through and type it in your calculator. Make sure you put your little caret here.
Is it 11?
Carrot cake.
I don't know what it is because someone has my calculator.
I did not have your calculator.
I was going to say,
You
that's
should
not.
blame me.
I'm not blaming you.
If you got that 5,000.
You better not get 5,000
It's
because
11,387.
11,300. Anybody confirm?
I got
Yeah.
Mine too.
Got that.
So 11,000.
387 and 90.
So this is how much money is in the account after 15 years with that interest rate compounding monthly.
Nice.
Not bad. How much is of it? How much of it is from interest? 6,000.
What?
The amount of interest earned is the difference between those two numbers. What? You and me.
I think she's doing it.
I overflow.
Broken.
What the heck is that?
What'd she do?
You can't do that. You have to type in everything.
I did. I tried to do it earlier and it kept on coming out 5,000.
You put a parentheses here, it doesn't go there. Why'd you put a parentheses there? It doesn't go there. Too many parentheses. You only put the ones that are on the board. You put one here.
No, and
Yes.
yeah, you
That-
have to.
there's no parentheses here.
For
It has
some of
to
our
be-
calculators, we have to do that if you want to make it
But
seem
you
like
could
it's a
do double
fraction.
parentheses.
I know, but you don't want that to be, it's just 0.055 divided by 12. It's one number. I don't want it a fraction. I just want it as the calculation.
We have to put it in.
No, you have to.
Well, if you put it in parentheses, if you start one here, you better end it right
Yeah,
there.
that's
and
what
have
I'm saying.
double
And then have two.
parentheses.
Yeah, that's.
But I'd rather you not even do that.
Well, you have
But you
You
have
have
to.
to. You have to.
Not in
put
this
it-
calculator.
If you
Yeah,
do
you
one
Not
plus,
on that calculator either.
if you do 1 plus 0.55,
Divided by 12. It gives you the right answer. Try it. Get rid of these parentheses.
Silly goose.
It gives you the right answer. It understands the order of operations. It understands that division's going to happen first and then it adds back 1.
Intriguing.
Calculators only know
Hers does. That one doesn't do it.
Yeah, me. It's mine. It does do it. I do it all the time.
I just did it.
How you're typing it in.
Let me proof. It can't be done.
What's wrong with that? That's just the inside.
It's the same.
No, type the whole thing.
That's
in.
the same.
Yeah, it's.
Type the whole thing in. 5,000 parentheses 1 plus 0.055 divided by 12 parentheses caret. Parentheses 12 times 15.
Carrot cake.
All right. What if?
You just made me hungry.
Almost always like Ruben.
Red velvet cake.
Let n equal 1,000. Do the same calculation, but let n equal 1,000.
Is that looks like an H
Where?
under your R over H.
Yeah.
N.
Buddy.
N. My H's are, really emphasized. N equals 1,000. 1,000.
11.
So it's divided by 1,000. 10, 12.
11,000.
409. 14 cents.
14 cents. Ooh, we made some more money, but not
Not
quite a lot. That's kind of weird. You'd expect to make tons more. I mean, you're raising this thing to 12 times 1,000. All right, let n equal 100,000. I don't know what'll happen to your
Would
calculators,
be 1,000 times.
which is 15,000.
You said 12
because
times
the
1,000.
1,000 is on the bottom of
Oh.
0.055, it makes it smaller.
12 times 1,000. Yeah, it makes this one smaller. So the inside gets smaller, the outside gets bigger, which is kind of like
11,409.
Yeah.
That's what
What is it?
Show us.
11,409.
11,409.40.
0.40.
Ooh, we gained some pennies.
Yay.
So what's happening here is, as we make this thing get bigger and bigger and bigger, it's approaching
It's approaching.
a single value again, kind of like this. So there must be this buried in this idea.
Maybe.
Yep.
Oh, it is. And I'm going to show you.
The guy out Jurassic Park.
Jurassic Park.
I'll show
This is not Jurassic Park.
Yes, it is.
So now let n go to infinity. Let's just look at p parentheses 1 plus r over n raised to the t and see what happens to this formula. Let's leave a on the other side. It really doesn't matter.
What happened to n?
You got rid of it.
What's that?
Why did they get
We
rid
forgot
of the
about
n
t.
Oh,
and the exponent but not the
NT.
n?
Sorry.
I have a question.
Go for it.
It's not related to math.
Oh.
We have like all as high schoolers, we have a teacher work day.
Yeah, I know, on Monday.
Yeah,
You still have to come here, yeah.
So guess what?
You still show up here.
You still show up here.
What we do, so we
Yeah.
still have class. Okay.
Yeah. Why wouldn't we?
I mean, I didn't know.
I'll be standing here teaching, so if you're not here, I'm still teaching.
Okay.
I was going to say that by the end of class.
We could Skype.
Yeah.
You can Skype it, yeah.
We can say.
I need this thing to look like 1 plus 1 over x raised to the x power. So I want to kind of manipulate this thing around. Now, first manipulation. This is definitely not 1 over something. Can I make it 1 over something?
You're going to anyway.
I'm going to, but how do you do it? How do I take r over n and rate it as 1 over something that's
You
equal?
can have that at 100%.
Stop that.
Yep.
Or
Okay,
what?
how about this?
Exactly right.
How do you write 2 as 1 over something?
Two.
Negative
Oh wait, 1/2 to the negative first.
Well, 1 over
2.
1/2.
Oh.
Because if
Yeah.
you multiply by the reciprocal, you're back to 2. How do you write 2/3 as 1 over something?
1 over
1 over 3/2. So if I want to write r over n as something 1 over it, I would write it a equals p parentheses 1 plus 1 over n over r raised to the n t.
Not rated
Now, this gets it closer to looking like
like that
this.
thing.
That's my whole goal. That 1 plus 1 over x thing. Now, I need this to be a single variable, so I can shoot it off to infinity. So I'm going to let it equal, it really doesn't matter, I'm going to let it equal u. So let u equal n over r,
So it'd be 1 over u.
or should I just let it be x?
Let it be x.
Let it be x, okay. X equals n over r. Since I haven't used x, I can use it. So that'll replace n over r with
X.
x. But I also have to get rid of this n too, because n is the one that's going off to infinity, and here it disappeared. So what's n equal to in this case?
X over times R.
X times r.
XR.
So I can replace this n with
XR.
xr, just doing a little substitution. So do these two substitutions.
What's that for? X.
XR2.
Yeah, x equals n over r. I'm just going to choose a variable to represent this.
Okay.
Once I choose that, I got rid of my n, so I have to replace this n with something else.
Okay.
So I multiplied both sides by r here and got n equals xr.
Looks like XR.
Alright, so we get a equals p parentheses 1 plus 1 over x raised to the xrt. xrt. Great.
Now what?
Now what? Well, we're basically done. Power to a power, you multiply, right?
Yeah.
Power to a power, you
Oh
multiply.
yeah.
You know,
Yeah.
a to the m raised to the n is the
Yeah.
same thing as a to the m n.
Yeah.
So if I have a product, I can separate it as a power to a power. Well, here I have a product, and I can separate it as a power to a power. So I'm going to insert brackets. I'm going to insert a bracket here,
Of course you
and a bracket here.
Why do you keep on these things? Oh,
Oh, doesn't it look like that?
yeah.
Yeah. So remember, n was going off to infinity. Well, now I have a problem. As n goes off to infinity, he's here, right?
Uh-huh.
What does x do?
So it goes off to something else.
Does it? As n gets bigger and bigger on this side of the equation, r is held constant. It's like 0.05, whatever it is. So n is getting bigger and bigger and bigger. What happens to the other side if it's equal? But how?
It goes
It goes down.
Does it decay?
Okay, ready? If x is equal to n over 2, and I let n equal 100, what's x equal?
50.
If I let n equal 1,000, what's x equal?
500.
If I let n equal 1,000,000.
Yeah, okay, so x grows.
So as n gets bigger, so does x. It's called the direct proportion. Remember ever hearing those words?
Yep.
So as n goes to infinity, x also goes to infinity. So if I do the limit on this little piece here, as x goes off to infinity, there's more reasons why this works, but I can't get into that. That piece turns into, what does this equal when n? E. So this becomes a equals p e raised to the rt. This is the Pert formula, as in the shampoo. That's how I always remember that. Pert shampoo.
There's a Pert shampoo.
Oh.
I used it way back when I had,
Hair.
it's probably Pert that made my hair fall out. You never know.
Probably.
So this is
That's probably.
continuous,
No, he says it because he made fun of his friend. Yeah.
that too, compounded.
My hair.
Aside.
Yeah, I used to pick on my dad for being bald and he cursed me.
I make
Yeah.
fun of you because I'm tall.
Huh? Yeah, you're gonna go bald now.
I'm a woman.
It
That's
doesn't
little
matter.
Miley Cyrus.
What are you talking about?
She's getting Miley Cyrus.
Oh,
Miley
no, I'm
Cyrus.
not.
We'll come back to that formula when we do word problems in section 5.
Yeah, we're
A
not,
equals Pert.
not getting your head out.
A equals Pert. Oh, we still have some time.
Oh, we don't. Dude, I
Yeah.
got a curfew, guys.
Two. Oh my god, no you're not.
So, if I want to graph this new function, f of x is equal to e to the x. F of x equals e to the x. What's it going to look like? Well, the first thing you have to determine is e bigger than 1, question mark.
Yeah.
Yes, it's 2.128, blah, blah, blah. So, yes.
Equal.
So since it is bigger than 1, it has the same exponential look. It goes through the point 0, 1. It hugs the x-axis on the left, it hits this point, and it shoots off. It just grows a little bit faster than 2 to the x. A little bit faster than 2 to the x. So that would be e to the x.
So it's kind of steeper.
It's a little bit steeper. What about e to the negative x?
It goes over the
What would it look like?
upside down.
Upside down. Does it flip over the x-axis?
Oh no, the
Flips over the y-axis. So it still goes through this point, 0, 1. But where's the horizontal asymptote? On the left or the right?
Alright.
The right, so it's down this way. I always suggest that you go for the horizontal asymptote first and worry about where it grows second, because the horizontal asymptote is much more important than drawing this piece, which is really easy. It goes straight up. By the way, these two functions are incredibly powerful in pretty much every math going. E to the x and e to the negative x. They even define new functions which are really cool.
You mean?
No.
You really want to know?
Sam,
Yes,
stop.
I
No, you can talk
You
about
can
this at home.
have-
at dinner
yeah.
table.
We're having hamburger.
You have seen this function before, right?
Yes.
Sine. There's also this function.
Are you answering Sam's question?
Have you ever seen that one?
Sine H.
Sine with an h at the end of it.
Since-
This is called hyperbolic sine.
Are you?
And the hyperbolic sine is defined to be e to the x
Sam.
You want us to write this down?
minus, no, e to the minus x over 2. So it takes these two functions, adds them together, and you get this new function called hyperbolic sine. So they're
Y'all
really,
can
really
discuss
cool.
this at the dinner table.
Yeah.
Dinner table.
Hamburger tonight.
I can't talk
No,
math
I
at
don't-
home.
Nobody
Wife
won't
really
let me.
eats at the dinner table.
Yeah, we don't eat it at the dinner
Go ahead.
table either.
Put a negative beside the x, that just flips it over the y.
Flips over the y. Yeah, it's changing the x value, not the y value. If you put a negative in front of the e to the x, then it flips over the x-axis.
Well, we can get confused.
Yay? Get confused? I'm confused. So let's use a equals Pert.
It flips it over.
If a of t is equal to 500 e to the 0.03 t, and I ask you to find a of negative 3, what's it equal?
Ask.
500
Let's plug it in there.
You need to select it in your calculator. Now to get E on your calculator, y'all know how to do that?
Right.
Yes,
Yeah.
Second ln.
division.
Second ln.
Second one.
Where's that
Alien,
at?
right?
Second ln.
I said that.
Oh, I see it.
Not EE as in exponential notation. E as in the function E.
I wasn't talking about
Second ln.
it. I know, I found it. I know
Oh.
what it is.
You said the.
Squeeze me. I got a negative.
Now, when you get this in the calculator, it's going to go E, well, at least on the smaller ones, it'll go E caret parentheses. It'll give you all that.
Yeah.
All you have to type in is 0.03 times
-3.
-3. And make sure you put -3 and not -3.
Also, it's just one bracket.
456.96.
456,
0.96.
96.
55.
Blah, blah, blah.
92.
But it gives you a number. This is how much money, if you had $500 today, this is how much money you had 3 years ago under continuous compounding.
Wow.
You can go backwards with money to see where you came from. See where
What
you
E
came
is?
What is that?
from. Continuous compounding. You get interest every millisecond of the day. Yeah, it's crazy. All the time you're gaining interest.
So you can put like negative
Oh.
1,000 in there.
Well,
That's
You
why.
can put like negative 1,000 in there.
If you
We'll
gain,
be doing that eventually.
would you gain more money if you did it monthly than if you did
No, compounding continuously is the maximum you're ever going to get out of money.
So I had.
What bank gives you continuous compounding though? None.
Wait, so
Sekou.
could,
Sekou.
is this like a